Okay folks, this is my first video with you guys. I hope you're doing well. Today I get to tell you a little story about numbers and integers. This is the video for 6+7+ compacted math for period 5 only. If you're not in that class, stop and find the right video. We're going to be doing pages 4 and 5, so you need to have your pencil ready. Remember, at any time, you can stop the video, re-listen to it, write things down, whatever. So here we go. First of all, long time ago, when there were cave people, I shouldn't say cavemen because that's not politically correct. When there were cave people, the very first cave people did not know much about numbers. So at the very beginning, they only knew about numbers called counting numbers. Sometimes they're called natural numbers. Now I'm in the smallest little section here on this page. This is page 4. So the earliest people thinking about math were thinking, a bone, 1 bone, 2 bone, 3 bone. And that was all they could do. They could count regular numbers like 1, 2, 3, ... right? But then some brilliant caveman realized one day that he was hungry. And he realized he didn't have any bones. He discovered the whole numbers. The only difference is 0. ... But then, that caveman who figured out no bone, he decided to do something about it. So he snuck into a nearby cave. No other cavemen were looking, and he snatched a bone. Right? So then he goes, oh. But then the caveman that he stole it from peeked around the corner and saw that bone in his cave and said, oh! And what did he do? Well, first of all, when he borrowed that bone, we come to the next level, which is integers. Integers are simply borrowing, but they're still whole bones. So here is where we are today. Integers. Now integers are borrowing and paying back, but they're all whole values. So it could be -3, -2, -1, 0, 1, 2, 3, etc. We're going to learn more about that word in a minute. I just want you to understand how integers fit into the math of all numbers. Well, when that caveman realized that another caveman had borrowed without permission, he took that bone and smashed it over that caveman's head, and what did we get? We got a lot of little pieces. Pieces of numbers are the next step. Right after integers, you get what's called rational numbers. Rational numbers are pieces. What do we think of when we think of pieces? We think of fractions. We think of decimals. Now, there are two kinds of decimals that fit into this category. Decimals that repeat the exact same thing over and over, like 0.12, 1, 2, 1, 2, 1, 2, 1, 2, forever. Or decimals that terminate, which simply means they stop. 0.5, it stopped. So that's a terminating decimal. Repeating and terminating. Now, a decimal with a pattern might not be a repeating pattern. Like if you say 0.12, 112, 1112, 11112, that doesn't repeat the exact same thing. So that kind of decimal would not be rational. These two types of decimals can turn into fractions. Therefore, these are rational numbers. Look inside the word rational and you'll see ratio. A ratio is a fraction. All of these can be negative. You can have a negative something, just a negative decimal, a negative fraction. All counting numbers are whole numbers. All counting in whole are integers. All counting in whole and integers are rational. So now let's look a little big picture. Notice that all of these were in one giant bubble, but this box is not connected or nested within the others. This one's all by itself. These are called irrational. Irrational means it doesn't make sense. It also means you can't have a ratio, or it can't be written as a fraction. And these are decimals that don't terminate or repeat. So that's irrational, can't be written as a fraction. All of these are called real numbers. Every one of these is out there in the real world. Irrational number decimals are often used in things like codes because there's no pattern, so it's good for a code for a security system or something. Now down at the bottom of the page, there's an extra box. It's not a real number. This is non-real numbers. Non-real numbers are some strange numbers that are useful to think about, but they're not actual numbers, like infinity, like I. I is the imaginary number which equals the square root of -1, and we'll talk a little bit about that a little bit later, but you can't have a square root of a negative, so that's the imaginary number. Non-real numbers, you could even say something like 11d7, because that's not real. So down at the bottom, write a quick summary of what you've learned about the map of numbers, or anything that you discovered that you didn't know, and that's a spot for you. And then join me on the next page, page 5. Real basics. What's an integer? A positive, negative, or zero whole number. Whole means no pieces. You can't have decimals, you can't have fractions. It's a whole number that's positive, negative, or zero. And don't tell me they're just negative numbers, because you're skipping positives and zero. How do you pronounce it? How many R's are in the word? 1. It is an integer, not an integer. That sounds as bad as it looks when you say it. So, how to pronounce it? Integer. That's a J, not a G. Don't call them integers. Numbers that are integers: 0, -1, 7. Numbers that aren't integers: 1/2, -11.5. Now, words that mean positive, things that might indicate that you're going to be doing a positive integer: above, right? Let's see, putting money into a bank account. So think about words that might mean putting money in, and you add some more, and we'll talk about these tomorrow. Words that might mean negative: below, like below sea level. What are some words that mean taking money out of a bank account? And don't write taking money out of a bank account. That's not what I'm looking for. See if you can find a bigger word. If not, we're going to fill it in tomorrow. But see if you can think of more words that might indicate they're talking about a positive number or they're talking about a negative number. And let's keep going. Opposite. An opposite is the same number on the other side of 0. So if you're at positive 7, the opposite would be negative 7. If you're at negative 12, 12 away from 0 on the left, you'd become positive 12, 12 away from 0 on the right. That's all an opposite is. Absolute value is very different. Don't mix these two up. They mean different things. This means distance from 0. That's it. How far is 7 away from 0? 7. How far is negative 7 away from 0? 7 spaces away. How far is negative 12 away from 0? 12 spaces away. How far is positive 12 away from 0? 12 spaces away. What is the absolute value of 0? 0. It's no distance from itself. What do you notice about absolute value? It's always positive, because the distance doesn't matter. If I get in a truck and I drive 4 feet forward, how far did I go? 4 feet. If I get in that truck and I drive 4 feet backward, how far did I go? 4 feet. Even though forward would be like positive 4 and backward would be like negative 4, the distance is still 4. So it's always positive because it doesn't matter which direction. So how do you graph these on a number line? Let's say your integer is negative 2. Your opposite would be positive 2. The absolute value is how far is negative 2 from 0? 2. So let's graph the integer negative 2 on a number line. Here's a number line. I need a 0, here's negative 1, here's negative 2. To graph a number, that's not enough. All that is labeled. To be graphed, you need a dot at negative 2. Now I have graphed the point negative 2. You pick another integer, write its opposite, its absolute value, and graph it on this one. We'll check that tomorrow. And then write a quick summary about what you learned today. Any questions? Come in tomorrow. Write down your questions on what I have learned today if you had a question about that. Have a great night, guys. I'll see you tomorrow.